Hello everyone, welcome to my channel Chemistry is Fun. Today we will deal with a topic. The name is quantum numbers. This is the topic today we will deal. It will help us to explain about electrons. The position of the electron, that is we have already studied about orbitals, that is the space in which the chances or probability of finding an electron is maximum, that is the orbital. So the shape of the orbital, the orientation of the orbital, which in turn explains the electron, can be explained with the help of quantum numbers. So in short, we can say that the electron in an atom can be explained by four quantum numbers. The first one is principal quantum number. It helps to explain the position and energy of the electrons in an orbit. It is denoted by n. The value of n can be anything from 1 to infinity. 1 up to infinity. 1, 2, 3, 4 up to infinity. The position of the electron can be defined if we know the radius. The radius of the shell, where n is the shell number, that is the orbit, Rn gives the radius for that orbit. We can use the formula Rn equal to n square a naught by z. Z is the atomic number. With this formula we can find out the radius. Once we know the radius, we can easily find out the position of the electron. The energy is also defined within this quantum number. Energy can be calculated by the formula En equal to minus 13.6 z square by n square, where again n is the shell number, z is the atomic number. Next is angular momentum quantum number. We also call it as azimuthal quantum number. It is denoted by small l, like this. It is denoted by small l. N can have any value from 0 up to n minus 1. That is, if n equal to 2, L can be 0 and 1. If n equal to 3, L can be 0, 1, 2. So up to n minus 1, one value less than n will be the value for L. They help us to describe the subshell. Subshells means like they are well defined by the value of L. When L equal to 0, the subshell will be termed as S. It means sharp. It is the short form for sharp. When L equal to 1, it is P subshell, means principal. When L is 2, subshell will be D, which is the short form for diffused. When L is 3, we get F subshell, that is fundamental. So we can also say that, for example, when n equal to 2, the values of L can be 0 and 1. So one thing we see, the value of n decides how many values of L are possible. N is 2. So number of possible values for L is also 2. First value is 0, second value is 1. So in this there is the possibility of S subshell and P subshell. So we find that we have 2S and 2P. Both are there. So this is denoted as NL. This is the NL denotation, like 2 is N, S is L. So NL. We can write a subshell as NL. We find that the value for L is always less than 1, less than N. L is always less than N, that is at least 1 less than N. If N is 3, L value can be up to 2. L is having more than one value. It may have one value or more than one value, but its value is always less than N. The total subshells is equal to numerical value of N. We have just seen here, when N equal to 2, The number of values for L is also 2, that is 0 and 1. From L we get the shape of orbital. L is 0 means s orbital, that is spherical in shape. L is 1 means p orbital, it is dumbbell in shape. When L equal to 2 it is d orbital, it is double dumbbell shaped. In this we also study the magnitude of magnetic moment. The magnitude of magnetic moment is given by mu L equal to EH by 4 pi mc square root of L into L plus 1. Using this formula we can find out the magnetic moment, where E is the charge on electron, m is the mass of electron. Next we have to study magnetic quantum number. It is denoted by small m. The value for m depends on the value of L, which you have just seen. So m or ml can have values from minus L to L. That is, if L equal to 2, m will be equal to minus 2, minus 1, 0, plus 1 and plus 2. These are the values for m. So you see, when L equal to 2 means it is d subshell having 5 orbitals. D subshell having 5 orbitals. So m helps us to tell us the direction in space. So as you have just seen, the total value of m will be equal to 2 into L plus 1. So when L equal to 2, m values of m will be equal to 2L plus 1, that is equal to 2 into 2 plus 1, that is 4 plus 1 equal to 5. There are 5 values we have just seen, minus 2, minus 1, 0, plus 1 and plus 2. Total 5 values are possible. So 12 plus 1 gives the possibility of number of values of m. This quantum number helps us to denote number of orbitals in a subshell. As we have just seen, there are 5 orbitals in the d subshell, 5d orbitals. They all are identical in energy, shape and size. They differ only in direction in space. Only their direction in space may be different. In p subshell there are 3 orbitals, px, py and pz. Px, py and pz, because in case of p subshell L equal to 1, so it will be 2 into 1 plus 1, that is 3. Px, py, pz are along this axis. Px will be along x axis, py along y axis, pz along z axis, as we can see in these figures. Next comes spin quantum number. The electron also spins on its axis. There are 2 possible spins, clockwise and anticlockwise. Sum of the spins is 0. Since it is spinning, there will be a spin angular momentum which is given by square root of s into s plus 1 into h by 2 pi, where s is half. We also can have a spin magnetic moment given by mu s equal to eh by 2 pi mc into square root of s into s plus 1. Thanks for watching my video. Please subscribe to my channel so as to stay updated with the latest videos whichever I upload. Thank you very much for watching my video. Please subscribe to my channel. Thank you.